Okay, I'm going to start section 7.2 now. 7.2 is really just some more with inverse trig functions. That's what they call it. So let's do some more with finding some exact values here. We've got some examples. Part A, suppose I want to find the value of sine of tangent inverse of 1/2. Okay, so how this calculation is going to go is I'm going to first let y be equal to tangent inverse of 1/2. Y equal tangent inverse of 1/2 means that tangent of y equals 1/2. And this is for values of y that are ranging between negative pi over 2 and pi over 2. We talked about the inverse trig functions worksheet here in the last videos. Here's how I'm getting those conditions on y for the tangent inverse curve. So I know that when I draw this triangle, it's going to be in quadrant 1 or quadrant 4. Opposite over hypotenuse, opposite over adjacent, both those are positive numbers, so I know I'm going to be in quadrant 1. The opposite side is 1, the adjacent side is 2, and now this isn't one of my common triangles. Okay, this isn't like a 30, 60, 90 or 45, 45, 90. And so the hypotenuse, let me just temporarily call that x. And if I use the Pythagorean theorem, 1 squared plus 2 squared equal x squared, means that x would be plus or minus root 5. X is the hypotenuse of the triangle, which is also the radius of the circle. That can't be a negative. So disregard the plus minus here for this problem. And x is equal to root 5, then it looks like. Okay, now I want to find sine of tangent inverse of y. And tangent inverse of 1/2. And I'm calling y tangent inverse of 1/2. So sine of tangent inverse of 1/2 would be the same as sine of y. And this triangle is built in terms of angle y. All right, so sine of an angle is where I take opposite over hypotenuse. The opposite side is 1. The hypotenuse is root 5. So 1 over root 5, that would be the exact value of this expression. Okay, part B, I want to find the exact value of cosine of sine inverse of negative 1/3. Well, I'm going to let y be equal to sine inverse of negative 1/3. Y equals sine inverse of negative 1/3 means that sine of y is negative 1/3. This is going to be for values of y that are ranging between negative pi over 2 and pi over 2. That's the range of the sine inverse function here. And so I'm going to be drawing this triangle in quadrant 1 or quadrant 4. Sine of an angle is opposite over hypotenuse. The opposite side is negative 1. The hypotenuse is 3. So since the opposite side is a negative, I know I'm going to be in quadrant 4 here for this. The hypotenuse is 3. And the adjacent side, I guess I don't know. I'll call that x. This isn't, again, this is not one of my common triangles. This is not a 30, 60, 90 or a 45, 45, 90. So to get x, I will again use the Pythagorean theorem. X squared plus negative 1 squared equal 3 squared would be my setup there. Solve for x, and you'll have x equal plus or minus 2 root 2 in simplified form. Now, the adjacent side is positive since you're going to the right of the center there, so I would disregard the plus minus. Sometimes we'll have an x value that'll be a negative here. So you got to pay attention to where the triangle is located there. Now, I want to find cosine of sine inverse of negative 1/3. Sine inverse of negative 1/3 is what I'm calling y. So I need to find cosine of y. This triangle that I built here is in terms of angle y. Cosine of an angle is where you take adjacent over a hypotenuse. The adjacent side is 2 root 2. The hypotenuse is 3. So 2 root 2 over 3, that would be the exact value. Part C, okay, we want to find cotangent of cosine inverse of negative root 3 over 3. Again, I'm going to call that, let's let y be cosine inverse of negative root 3 over 3. That would mean that cosine of y is negative root 3 over 3. And this is for values of y that are ranging between 0 and pi. That's the range of the cosine inverse function. Okay. And so when I draw this triangle, it's going to be either in quadrant 1 or quadrant 2 with these conditions here. Adjacent over hypotenuse. The adjacent side is a negative, root 3, so I'm going to be in quadrant 2. And the hypotenuse is 3. Okay, the opposite side, I'm going to call that x. This, again, would not be one of my common triangles. So to get x, let's use the Pythagorean theorem. X squared plus negative root 3, the quantity squared, equal 3 squared. If you solve for x, x would be plus or minus root 6. We'll want root 6 since we are above the center there. And, okay, cotangent of cosine inverse of negative root 3 over 3 would be the same as cotangent of y. And this triangle is built in terms of angle y. So cotangent of an angle, well, tangent of an angle is where I take opposite over adjacent. Cotangent of an angle would be the reciprocal of that, right? I want the adjacent over the opposite side. The adjacent side is negative root 3. The opposite side is root 6. If you combine these to a single radical, negative, the square root of 3 over 6 is 1/2, right? And then the square root of 1 is 1. So negative 1 over root 2, that would be my answer if I don't rationalize the denominator there. Okay, and that would be the exact value of this expression. Okay, we'll do some more with exact values here. So find the exact value. Okay, what if we want to know the exact value of cosecant inverse of 2? Well, if I call that y equal cosecant inverse of 2 means that cosecant of y is 2. The range of the cosecant inverse curve is where y is ranging from negative pi over 2 to pi over 2, but y can't be 0. Okay, and so I've got that stated here. Now, we're not going to have to worry about y being 0 here in this problem, but I'm going to be drawing this triangle in quadrant 1 or quadrant 4. It's going to be in quadrant 1 since 2 over 1 is positive, and both of those numbers. Now, sine of an angle is opposite over hypotenuse, so cosecant of an angle would be the reciprocal of that. It would be hypotenuse over opposite, right? So in this triangle, the hypotenuse is 2, the opposite side is 1, and the adjacent side would be root 3. This is one of my common triangles. This is a 30, 60, 90 right triangle, right? I'm working with a 30-degree angle. And so pi over 6 would be the exact value of cosecant inverse of 2. Okay. How about what if we want to find cotangent inverse of negative 1 over root 3? We'll call that y. Y equal cotangent inverse of negative 1 over root 3 means that cotangent of y is negative 1 over root 3. The range of the cotangent inverse curve is 0 to pi. Okay, so I'm going to be in quadrant 1 or quadrant 2. Cotangent of an angle is adjacent over opposite. So that adjacent side is a negative. I'm going to be in quadrant 2 then. The adjacent side is negative 1. The opposite side is root 3. And the hypotenuse is 2. This is, again, one of my common triangles. This is a 30, 60, 90 triangle, but we're in quadrant 2, right? And we're working with a 120-degree angle then, or 2 pi over 3 would be that answer in radian measure. Okay, now on the next page, I've got this calculation again, the same one, but I've miscalculated. Okay, what's wrong with the calculation? Well, I have y equals cotangent inverse of negative 1 over root 3. That means that cotangent of y is negative 1 over root 3, and for the condition that y is between 0 and pi. Now, tangent of y is the reciprocal of cotangent of y, right? So cotangent of y would be the same as 1 over tangent of y. So why not write it like that? If I cross multiply, tangent of y would be negative root 3 over 1. Now the range of the tangent inverse curve is y is ranging from negative pi over 2 to pi over 2. So I'm being quadrant 1 or quadrant 4. Well, opposite over adjacent, the opposite side is a negative, so I'll be in quadrant 4 here. Opposite side is negative root 3, the adjacent side is 1. Hypotenuse would be 2. That would be negative pi over 3 then, for the angle that you're describing, which is between negative pi over 2 and pi over 2. Right? So why isn't the answer negative pi over 3? Well, the problem with this calculation is that we have just changed the range. Right? We said right at the beginning that y has to be between 0 and pi. Y is not going to change from that condition. And that's what we've just done, right? We have changed the condition on y, and that led to a wrong answer. Okay, so the point of this is to say that we don't want to use the reciprocal identity in this problem. Sometimes it's okay, sometimes it's not okay, but you don't want to change the range that is there in the problem. You don't want to change the conditions on y, in other words. Okay, let's take a look at, I've got 2 more examples here. So in these last 2 examples, we're going to use a calculator to approximate each value. Suppose that I want to find the value of secant inverse of 3. Okay, well, I'll call that y. Y equals secant inverse of 3 means that secant of y is 3 for the condition that y is between 0 and pi. Y can't be pi over 2, though. Okay, now I'm going to use a calculator, but that's not going to come till later. You see, on my calculator and on most calculators, if it's a graphing calculator, like you got a sine inverse option, you got a cosine inverse option, you got a tangent inverse option. There is no cosecant inverse button or secant inverse button or cotangent inverse button, right? Even on the higher tech calculators, you won't find that, which I like. Because it actually forces you to think about the problem a little bit rather than just blindly typing in things on the calculator. So let's see. The work that I'm doing here, I have to find secant of y equal 3 under the condition that y is between 0 and pi. Well, let's see. Secant of y, that's the same as 1 over cosine of y, right? The way that we define secant of an angle is that it's the reciprocal of cosine of that angle. Now, there is no harm with using the reciprocal identity in this problem. You know, there was an issue earlier in the last one because it led to a wrong answer. Okay, but that's not going to be a problem here because the range of the cosine inverse function is the same conditions on y, right? I'm not changing the condition in that y is between 0 and pi, and that was the problem in the last one that we did. We were changing the conditions on y. So secant of y, that's same as 1 over cosine of y. If you cross multiply, cosine of y is 1/3. Now the nice thing about using the reciprocal identity here is because, as I just mentioned, I do have a cosine inverse button, right? So if cosine of y is 1/3 and I take cosine inverse of both sides, y equal cosine inverse of 1/3 means that now I can use the calculator. Okay, so let me go ahead and enter that in. I'm in radian mode, so cosine inverse of 1/3 is about 1.23 if you go nearest 2 digits. And that's what we were getting. Okay, so secant inverse of 3, that would also be 1.23, roughly. Okay. Of course, there was no problem in using the reciprocal identity here because the condition on y was the same. Let's try one more. So what if I want to find the value of cotangent inverse of 1/2? I'll call that y. And of course, I don't have a cotangent inverse button, right? I got a tangent inverse button, but that's not going to help me here in this problem. So I will have some work to do before I go to the calculator. Y equal cotangent inverse of 1/2 means that cotangent of y is 1/2 for when y is ranging between 0 and pi. That's the condition on the range of the cotangent inverse function. And okay, so cotangent of an angle is adjacent over opposite. The adjacent side is 1, the opposite side is 2. And this is not one of my common triangles, so I'm going to call the hypotenuse x. And to get x, we'll use the Pythagorean theorem. 1 squared plus 2 squared equal x squared means that x would be plus or minus root 5. You're going to ignore the plus minus, though, because x is the hypotenuse of this triangle, also the radius of the circle, which can't ever be a negative. Okay, now cotangent of y equal 1/2 means that I can't use the reciprocal identity. Like, I wouldn't want to look at this as 1 over tangent of y equal 1/2, equal 1/2. Okay, because then I'd be changing the conditions on y. So that would be a mistake. Okay, but this triangle is built in terms of y, and the cosine inverse function has the same conditions on y as the cotangent inverse function. Okay, if you omit the endpoints, which we're not going to need 0 or pi in this calculation. So there's no problem with looking at this triangle and computing cosine of y. Okay, because we're not changing the conditions on y. Well, cosine of an angle is where we take adjacent over hypotenuse. Adjacent side is 1, hypotenuse is root 5. Cosine of y equal 1 over root 5 means I can then take cosine inverse of both sides, and the nice thing about doing that is because now I can use my calculator. I couldn't use my calculator early on, but now I can do that here. So I want to find cosine inverse of 1 over root 5, and I'm getting roughly 1.11, which is what we have there. So cotangent inverse of 1/2 is roughly 1.11. As a rule of thumb, whenever you're using the cotangent inverse function, rewrite using the cosine inverse function, because the range is going to be the same except for the two values, the two endpoints, which, more times than not are going to be not relevant to the problem. For cosecant inverse and secant inverse functions, you can just use the reciprocals to get y. That's what I was doing here in part A, where I was using the reciprocal identity. Okay. So that's it for section 7.2. The homework is on page 467.